All right, we got the next installment of the podcast here, and we are delighted to have Dan join us from a renowned New York City architecture firm. And this episode is going to be really based around sustainability and really the evolution of what Dan has seen in New York City over the past couple decades, and really how new systems and technologies have emerged and been, call it, received by the marketplace. So before I start digging and asking you guys questions, it'd be good to hear how the two of you met.
Oh man, I don't actually remember the context, but I think it was just interaction between the Schuco sales office in New York and your firm, possibly through Brad Davis at the time. He maybe made the connection.
Yeah, I remember I'd gotten involved in Passive House back in like the, I don't know, 2015, something like that, 2016. And we did a big report for NYSERDA
Right.
describing how to design Passive House for tall residential buildings, which was happening at the same time as the Cornell Tech building was being designed. So like independent of that, unfortunately, our developer was runner-up on that, so we didn't get that one. But instead, we did this big NYSERDA report, and I understand that report is still used in as like in the syllabus or whatever reading list for Passive House training. But anyway, yeah, I'd done a bunch of research and was grilling you guys about details. But then there's been other projects we've worked on. I think, did you help us with the Statue of Liberty Museum?
Yeah, I wasn't involved too much in that. I think initially I was in the very beginning, early on, but I certainly didn't get into the nitty-gritty details of it.
Yeah.
But yeah, that NYSERDA report was fascinating because it was kind of like a case study, like proof of concept almost, that was proposed before the Passive House criteria was really kind of validated for high-rise construction in New York. I mean, there was a lot of speculation about how it could be successful. I mean, Cornell Tech was kind of the first, let's say, successful project where they kind of did they did it and they pulled it off.
Yeah.
But yeah, the glazing package was always really challenging, and that's how we came into it, was to try and give you the data, at least to kind of validate that hitting the goals was doable with the current technology platforms that we had in the market. So
that's right.
So do you think, I always kind of make fun of Spencer that he went to facade school in Germany 12 years ago maybe, and focused on Passive House, and so he was always kind of the outlier stepchild in this country trying to push Passive House, and nobody wanted to hear it. And now all of a sudden he feels heard and everybody wants to talk to him. So
yeah, I mean, it's kind of interesting, like the Schuko stuff, in Germany they've been doing it for a long time, right? And we're kind of like trying to encourage people to do it in the US as sort of this like upsell. But then now it's like the criteria, once you balance it against the mechanical loads and you can kind of reallocate, that cost from the mechanical systems to the facade, you just get a more comfortable building, and then obviously the needle doesn't really move until the building code changes, right? As soon as the energy code improves, that's when people really start kind of getting on board. So yeah, it's been something we've been pitching for a long time, but I feel like we're finally at like a moment where I feel like it's starting to really be implemented. I don't know if you see more of that, Dan, and what projects you're working on.
Yeah, we've had a constant stream of Passive House designs that haven't actually come to fruition, but we've got two of the finished construction documents and one. Well, okay, in terms of new construction, two of the finished CDs that haven't started yet. But then we have Rubin Hall, which is going to be the largest interfit project probably in the world, and it's nearing the end of construction. Students are going to move in a week or so.
Well, so before we get into that project, which I have too many questions on, and before we get more into Passive House, Dan, before Passive House was really a thing, earlier on in your career, was sustainability always a focus? And did you find it wasn't, call it, as well received by the community earlier on? And was that encouraging, discouraging for you?
Yeah, I was interested in sustainable architecture since high school, and it was hard to, exercise that interest because, you know, it wasn't really a focus in school, and then in the profession also wasn't a focus. So I ended up at FX Collaborative because in its earlier incarnations, back to Fox and Fowl, was a leader in that space, having done buildings like for Times Square, the kind of NAS building, which was like, you know, green before green for office buildings. So, you know, I came here and kind of was able to, you know, learn on the job. But then eventually, I remember I found, I like to say I found Passive House in the desert, because we were doing these LEED certified buildings in the desert climates, which were it's just totally bonkers and not the right thing to do. And so, you know, I looked for what was more reasonable. And then once I figured out what Passive House was really about, just quality construction, doing the right thing, and it made it seem like everything else is kind of a false advertising. Like, you know, you buy a house, right? Say you go to the suburbs, you buy a house or something. So, like, whoever's buying it probably expects that they're getting a certain level of quality, and it, like, I'd be upset if I really understood what I was getting. So Passive House is kind of just like, you know, what you should be doing, and it's
Yeah,
reasonable.
well, that whole false advertising idea, I was with someone having dinner with them in Boston last week, and he's doing a whole gut renovation and addition on his home, and he wants to try to make it net zero. And so he's asking about windows and this and this, and he's like, oh, well, this brand is better than this. And you almost ask yourself, like, from what? Because they spend more on marketing dollars, because they pitch themselves as the, you know, sustainable or better performing window. And so how much of that had you experienced with, call it, LEED and other initiatives over the years, and buildings trying to advertise themselves as LEED Gold or LEED Platinum or LEED Silver, the idea of just checking a benchmark versus actually making a difference and, you know, implementing a high performing building?
Yeah, no, I love LEED. LEED's great. It changed the market. They're rightly upgrading it to LEED version 5 now to keep up with things. You know, I think part of the reason why Passive House and Well and, like, you know, all these other systems have, there's been a lot of interest in other frameworks, is because of, you know, LEED wasn't good at those particular things, so there was a need to get at other aspects. Yeah, one of the things you can do in LEED is to have a building that doesn't really perform well in terms of energy reduction, and that's explicitly why, you know, what Passive House is good at. And, you know, things like air tightness are just kind of simple, easy things, but, you know, the energy credit in LEED has to do with modeling. It doesn't get into, like, you know, performance on site. So so that's a distinguishing factor.
And so I guess as an architect, I don't know how much of your involvement, what really over the years, is early SD, DD, CD phase versus being heavily involved in the actual construction and as-built conditions. But this whole paradigm shift around designing and modeling a high-performance building versus actually being accountable for what's being built, and things like Passive House, but even Local Law 97, which everybody's still wrapping their head around. So has that forced you on the architecture side to really develop more integration between your early design team and the actual team that might be going out there witnessing testing, witnessing as-built conditions?
Yeah, yeah. So, well, about me, I'm an architect. I've worked on everything from concept to CA, and now I'm the director of sustainability at my office. So, you know, kind of with an architect's perspective in that role. Yeah, yeah. I mean, on a day-to-day basis, it doesn't change that much, but, you know, the team that's doing you know, unit layouts is still going to do unit layouts. But, you know, from a kind of internal resources point of view, one of the things I've done here is implement envelope starting points. So we have these drawings now that are informed by all of our zone green and Passive House detailing, which, you know, I show to even our urban planners who are doing, you know, zoning, you know, zoning calculations for clients to see what fits in on a particular site, just to make sure they get the wall thickness right. So that's one way in which that gets integrated.
And to now kind of go to a specific project, the NYU dorm project. I think I can't tell you how many times I've been asked, I'm sure Spencer probably tenfold the amount I have, how can we actually execute a high-rise passive house building? How can a, all glass curtain wall be a passive house building? Do you see retrofitting an existing building being an even steeper mountain to climb? Some people say it's easier in some senses. Some people say it's harder. I'm sure there's an incredible amount that you've taken away from the process so far.
Yeah, that existing buildings are all difficult. They're all different. The particular complexities with this building. So, for example, there are some egress stairs where we just couldn't insulate at all because we couldn't reduce the egress width because they needed to keep their bed capacity. So, there are places, there are things like that you're always going to have to trade off. And I think there was some discussion between our passive house consultant and the certification body about what was acceptable and what wasn't acceptable in terms of interfit. But regardless of that certification, existing, we need to keep our existing building stock for embodied carbon reasons, and we need to find ways to use those buildings. So I'm totally okay with trade-offs that get significant improvements, but don't necessarily hit certification frameworks.
I think one thing that we might run into trouble with is we haven't really experienced this, I don't think, correct me if I'm wrong, in New York, but in Boston, the new stretch code has become so stringent that people don't even see an existing building envelope upgrade as feasible anymore. Whether it's limited access, they can't insulate from the interior exterior, or they just don't have enough, call it the means to hit the targeted values. So do you think we get to the point where codes just might make construction activity cost or design prohibitive?
That's interesting. I've only been involved in recently with a new construction building in Cambridge, dealing with those, and it's a passive house building, partly because that was going to be easier than complying with the other energy code methods. But in terms of an existing building, yeah, if they don't have ways to trade off for the complexities of existing buildings, then that's a problem. So Rubin Hall, for example, can't insulate the slab edge. There's just no way. So there are limitations that are very real that you have to deal with. But I think Rubin Hall is a great example because it worked around and with all of those limitations and is still a very successful all electric interfit building, and I think it's going to be a real example for the city for how to deal with tall existing buildings.
What is it that drove the decision on NYU's part? Was it their initiative? Was it partly you pushing? Was it a back and forth? What? And the next part of that I want to discuss is like being able to actually measure or articulate the cost delta between just meeting code versus upgrading to passive house. I've been told that you get to the point where it's a percentage or two on a hard construction cost premium to go passive house. So I would assume the more case studies that we have, it'll allow us to come up with a better selling point or case for the owner to consider. But back to NYU, were they pushing the initiative?
Yeah, like with any organization, there's certain champions, and there's I don't know, Cecil Scheib is the sustainability person there, and he's a huge advocate. And they ended up looking at. There was, I don't remember the numbers, but it was going to be just a little more for the triple glazed windows and all that, but a little more for the air testing. But there were two big factors. One is it's an historic district, and we can only fit a certain amount of HVAC equipment on the roof and still, maintain the, visibility, or hide the stuff on the roof. And we essentially had to get to that EnerFit level performance to keep that equipment small enough to be hidden.
Wow.
So like we had to do that anyway, like to get there. So then once we had to do all of that, you know, the delta to get the certification was, you know, kind of a drop in the bucket, I think. But also they really understood and appreciated the comfort and kind of qualitative benefits for students. That particular Rubin Hall had been, I think it was like the last dorm that they had not air conditioned. And there were, you know, it's like there were news stories about how hot it was in the building on certain days, and you know, students were unhappy. So, you know, in improving the comfort was going to have a very direct relationship on student wellness and happiness and you know, ability to study and test scores. So they took that seriously, and that was part of the decision making.
It's fun. It makes me think maybe 15 years ago, my sister was interning in New York City, and she uh, some type of stipend or something through housing through NYU, and she elected to commute an hour and a half outside of New Jersey just because it was so unbearable without the AC. But no, that hits home. So kind of moving on to newer technologies, what are some things at the moment, you know, we discussed a bit before, that you're seeing more implementation of? We talk about things like triple glazing and dynamic glazing and vacuum glazing. Uh, a lot of talk around it, but I really don't see widespread implementation of anything, call it new in New York. It seems like business as usual continues to be your double glazed IGU, aluminum frame glazing. So are there more talks on newer projects about utilizing newer technologies?
Yeah, yeah. I mean, of course, I've had samples of those things in the office for for 10 years. Um, but yeah, we have our first triple glazed office building is also nearing completion. It's a smaller boutique office building on 57th and among the super talls. Um, and that is triple glazed because that's how we were able to get to zone green and get an area bonus.
And did you
Um,
still have to utilize bird friendly, or that was
that
before?
was before. That was before. But so that's exciting, and I know of a number of other triple glazed uh, office buildings that are going on in the city. So, and I've heard anecdotally that the cost of triple glazing in the city is coming down, or getting, you know, not that much of an upcharge from double. So I, you know, I have high hopes for that. And we have looked at vacuum insulated glazing a couple times, most recently for a different historic building where we had to have stained glass, and for historic reasons we needed a bronze frame, and there was, you know, the glazing pocket could only be an inch because that's how they make bronze frames, and to have the um, stained glass and get some kind of U value, like that was, you know, vacuum insulated glazing was going to be the only thing that could fit there. I think we ended up doing something else besides that assembly, but you know, we very nearly used that approach in that historic building.
Spencer, why do you think people, I was thinking about this over the weekend, are so fixated on U value and coming up with the lowest achievable number? I think, you know, if you have a well insulated frame and a double glazed, double coated IGU, aren't there other factors we could be paying attention to, especially like solar heat gain, shading elements that could maybe move the needle more so than just targeting what's the lowest U value your window could achieve? I feel like that's the first question I always get asked.
Yeah, well, I think a lot of it has to do with the fact that the windows in general are the kind of the weak spot thermally in the envelope a lot of times, you know, in new construction at least. I mean, when you're dealing with retrofits, you know, as Dan was mentioning, you have structural conditions, stair conditions where you'll have major penetrations, but in general, it's the glazing package where you get a huge amount of heat loss and or the openings in the building, right? So finding a way to mitigate that becomes like pretty influential on the overall performance of the facade. And you know, it's also climate specific, right? We deal with a lot of projects in the Northeast in New York, heating dominated climates, right? your solar heat gain coefficients and your VT, I mean, they're important, but a lot of it depends on the exposure. Whereas if you're in these colder climates, you're always going to have heat loss through these weak areas in the envelope. So it's kind of like the low hanging fruit, you could say. And there's a lot of options to mitigate it. Like we have the technology to do a triple pane IGU very, relatively cost effectively with minimal impact on the building. So, I think that's kind of why it's so important because of its impact on the overall performance thermally. And, ultimately, if you start drilling into this topic, like the assembly of the window is important, but the holistic energy model is also really critical. Because you might have like a wonderful, super insulated frame, passive house level window, but if you have a bunch of thermal breaks, or a bunch of penetrations that are not thermally broken, or you have a bunch of air loss through the envelope, it kind of doesn't matter. So I think that there's also kind of a industry like marketing concept around it. It's very easy to just say like this is the U value of my window and it's so much better than my competitor, right? And it's sort of absent from context. So that's part of it too, I would say. But yeah, I think it's in large part due to the fact that it has such a huge impact on the heat loss.
And I would add the you know relative difference between a wall and a window. The wall, so it's like, I mean, I don't know, a wall could be R16 or something like code, and the window is less than 2 considering the
Yeah,
thermal bridging. So it's a hole, it's the proverbial pinhole in the balloon.
right.
And also,
And
I remember, never forget, I went to Glaze. I had to do a bird friendly class presentation at a glazing conference once, and I saw on the trade show floor there was a company that sold thermal struts, and they had this brochure of thermal struts, and it had like all the depths that you could get, and I'm like, oh my god, these exist.
Yeah,
Why don't window companies just buy the thicker ones? It's like, it seems so easy from a somebody who's not in the industry really, but I
yeah.
mean, I'm not in the glazing manufacturing industry, but it just seems like it's easy to fix.
well, Spencer, that has to come down to availability, right? I mean, for a while we were limited to what struts we could buy from Technoform, where you go overseas and they have all these complex shapes that are only accessible to, call it Schuko and others. But it's the same thing when it comes to triple glazing. I mean, you spoke on a prior episode about how business as usual in Europe is triple glazing. So you have this enormous set of fabricators you could choose from. Where here in the States, you get to complex, thicker lights or laminated with triple, you're only down to a few select fabricators.
Yeah, and a lot of it is just the platform, right? Like if you look at the window frame technology in North America, I mean, we're kind of moving out of the archetype of like poured into bridged thermal brakes, to strutted thermal brakes. And as soon as you start strutting and rolling two aluminum sections together, you have this modular thermal brake that you can increase the depth of. They've been doing that in Europe for a very long time already. So it's like all of that platform already exists. And now it's like we're going even beyond that, where it's like not just the depth, but it's like what is the actual material in between the two sections? So is it an air cavity or is it insulation? And then how good can you improve that material? Because if you improve that material, it has a huge magnitude effect on the overall window, which then affects like the overall facade, right? So it's like these little sort of moves on changing out materials, but it I guess it's that whole thing of you have an entire like set of building codes that's so much further ahead. There's already been like product innovation to meet those requirements and keep the cost as low as possible. And then, the US is like kind of now entering into that realm where it's like, oh, you see that there's multiple thermal break depths. I mean, that's been a thing in, European windows for like 15 years, 20 years. It's like not super new, but we just don't see it here because it hasn't really been a requirement until recently.
Dan, to go back on what you were talking about before with window versus wall and accounting for thermal bridging, what have you noticed in terms of educating colleagues or just knowledge spreading within to place more of an emphasis on all your transition details? And for really anybody in the industry, but a young architect who's uninformed, they might just say select the best brick veneer or rain screen cladding with your window and plop it all together. But just now, with how much awareness that there is around the degradation of the overall facade, given all the thermal bridging, are you relying more on facade consultants, relying on more of a design assist collaborative effort to target those areas? How has the firm or really the design community handled that added stress to make sure, or pressure to not overlook those weak areas?
I think that starts with just internally, I show people, you know, therm analyses of just some generic existing conditions and idealized conditions, and it's just kind of like visually obvious. And architects respond really well to that kind of visual, um, clarity. So when it's kind of like once you see something, you can't unsee it. It's so there's a certain amount of just internal education in using the right words and images. Um, but then I got to say that every project's a little different, and every client has they have ways they want to build, and I'm always trying to help teams optimize, and that looks different on every project. Some clients are willing to push a window out from uh, the structure that it's sitting on to align the thermal break, and some don't want to do that. I don't know. Just people have really strong feelings about how to build things, and changing that is a long-term process.
Yeah, Spencer, what are some of the more impactful sort of visualizations you've seen or that have stood out to you? I know the thermal imaging uh, snippets are powerful. I really like Elliot's kind of blower door testing, or he uses almost, what is it, the smoke test with the colored smoke to illustrate how much air loss infiltration is happening around the perimeter. And then people think about whistling and air quality and obviously meeting your thermal targets or heat loss. So all of a sudden it's that aha moment. Has anything stood out to you in that sense?
Yeah, I mean the simulations, the thermal heat flow simulations are great. What's even more powerful is thermal imaging from like constructed mock-ups or buildings. Like if you can show someone a picture of the heat flow through a facade of a building in winter, it kind of it illustrates the physics much more effectively, and it gives this kind of visceral representation of what's really going on with the heat flow. So we do that quite a bit. The other big tactic we use, the scare tactic, is condensation, right? Because no owner is interested in dealing with any kind of condensation on the inside of the facade. Like that's, just like a litigation, like just getting ready to be teed up, by the occupants right at some point, and like potential mold growth and all these other like horror stories like coming back out of the 90s, right? So we typically illustrate that sort of thing and point to condensation risk as it relates to like, the thermal continuity of the facade, and that's where like thermal bridging can be described like pretty effectively. It's like, well, actually, like this piece of metal is going to be so cold, you're going to have condensation developing here. And it's going to damage, your surfaces unless you move the window or you change this anchor or make the insulation continuous, and that's always been super effective, I found.
I was going to add another. There were during one of the polar vortices that's happened in the past bunch of years. There was one time, I think it was somewhere in the Midwest. There was like a social media phenomenon of people posting photos of like weird things that were happening in their house because it was so cold outside. And I have this one. I stole one of somebody's electrical outlet with ice on the inside of their electrical outlet, and the description had something to do with it was over their garage or something, and some addition on a house that was, and it was a perfect illustration of infiltration, you know, like wreaking havoc,
Yeah.
like ice on your electrical outlet.
Yeah.
I mean,
Like totally ridiculous, right? But
yeah,
it shows that's what can happen if you don't detail it correctly. It's incredible.
exactly.
Yeah.
Is there anything in, did you say it was version 5 of LEED that's coming out that accounts for thermal bridging? I mean, what is actually the hard rule around it?
I, I did a little bit of a review of version 5, but not that part. So I'm not sure. I know in general, Lead 5 is looking good, so I'm hopeful about it.
But in general, the prior versions, was it something that was overlooked?
Yeah, I don't think air tightness factored into it except for in energy modeling and in normal energy modeling processes. You know, Well, you know, okay, so there's been a couple of times where I've dealt with kind of normal ASHRAE type energy modeling side by side with passive house energy modeling, and always the normal approach seemed to undervalue the envelope performance characteristics, the effective R values, the and U values, the effective thermal bridging, the effective air tightness. So, you know, I've always been a little bit perplexed about why passive house modeling shows one thing and like this other modeling shows another. Um, I hope that's something that gets normalized in the future.
Yeah. Have you sort of on a little bit of a switch away from air tightness and U value, more on the solar heat gain side? Have you had any experience with dynamic glazing, the tintable glazing?
Yeah, we've looked at it for a few projects. I've, you know, been to a few showrooms to see it. Um, you know, there's a aesthetic impact. It's like, you know, sunglasses in the building casting a certain light, which is a little bit funny. And then there's I don't know if it's just a perception of complexity or real complexity about, you know, wiring, you know, a whole nother system together. So we haven't had a chance to actually implement it, but we've looked at it.
Yeah, I hear mixed reviews. You know, a lot of this is Spencer and I are dealing with a project right now at an institution where they need the operable windows to be ADA compliant with a specific look, and it looks like the only solution is to utilize motorized hardware. And you know, sure, everybody says that's great, it's innovative, it can work, but you're right that there is that added level of, all right, now you need to integrate it with your building control system. Now you need to bring on an electrical contractor. So it's not just a simple, let's throw that in there. And it feels like, I don't want to say people get stuck in their way, but if you get there too late, you're not going to get some monumental shift. These sort of newer technologies and innovative approaches, something tells me they have to be baked into the project early on or have to be discussion points early on. And if you're too late, it's just too much of a mountain to climb.
Yeah. Yeah, I mean, motorized stuff, BMS control of all of it, you know, it's interesting. I was in a passive house office building in, I think, Frankfurt, Germany once, where there were external shading devices that were, or, you know, like the roll down shade type that they have it's ubiquitous through Europe, and they were timed so that, you know, somebody working there could adjust it or roll it up or down, but then every 2 hours or so, they all reset to whatever their ideal set point was for that time of day. Um, so I mean, it worked. It seemed like it wasn't complicated, just standing there watching it happen. Um, yeah, but yeah, I guess, you know, additional expense and complexity, and I mean, building engineers have a hard enough time getting a hold of their BMS systems and making everything sing.
Yep. What was your experience like in that passive house office building or other passive house projects? Have you felt, maybe it wasn't under extreme outdoor conditions, but have you noticed a difference? Do you think there was a little bit of biases involved?
Biases? Well, I don't know. Yeah, I've been in many. One time I remember I brought one of the partners from my office to a house in Brooklyn here that was to an open house, and I brought my son at the time, who was 2, and to demonstrate the acoustic performance of the glass, I brought him out onto the balcony and let him scream because he was being very patient, and then I let him outside and he screamed at her through the window, and she couldn't really hear much, so that proved it to her.
Yeah, facade seems like one of those things where in order for it to click, it's like that Shark Tank moment. You really have to feel it and see it.
Yeah,
And someone has to be in, you know, a building with a lot of thermal bridging or
that's right.
uninsulated brick cavity walls for them to say, all right, I
Yeah,
need to blast my heat. This is just not
yeah.
feasible.
Oh yeah, I was in another one where there was a tour and then there was a bus stop outside, and the bus was there, and the person giving the tour was like, "Oh, did anybody hear that?" And everybody's like, "What are you talking about?" And then he pointed to the bus, and everybody's like, "Oh my God, it's what a revelation!" And then, you know, another thing is, you know, ERVs and filtering. You know, I mean, essentially, pandemic ventilation is, you know, I mean, passive house ventilation is the kind of ventilation that we need for pandemic safe, kind of wildfire smoke safe design, you know, with the right level of filtration and whatnot. I mean, it's amazing to me that we still can do. Sorry, I'm going on a tangent, but we still do many buildings that don't have dedicated outdoor air systems and rely on windows for fresh air. And those windows in the hottest days of the year, the coldest days of winter, or just some people never open them or close them because they just don't bother, and they're just not getting fresh air. I mean, how unhealthy is that?
It's kind of strange. I mean, New York, you have what, 5% of the floor area has to be naturally ventilated. So I go in all these other markets and they're like Dallas, Texas, Nashville, Tennessee. Why do we need operable windows? We just have our, mechanical system. But so you walk around New York City and all these buildings, new construction buildings, on a 68-degree day, 74-degree day in spring or fall, and all the windows are closed. And I'm thinking in my head, what is this instinctual thing? I mean, I would think if you're cooking, if you want fresh air, like who would not want to elect to have that in their living space?
Yeah, maybe it's an urban living thing. People just kind of expect the machine to work. I don't know, but I mean, obviously you need operable windows to let people, feel what they want to feel. But if they're not going to take charge of their own situation, you should give them fresh air, and it should be filtered.
Yep.
It's just
So
common sense to me.
On a closing note for Rubin Hall, it's a phenomenal project. I think a lot of people don't know about it. I think a lot of people don't realize that a large scale existing building can be retrofit to the Passive House standard. What will be the best way for people on this platform listening to learn more about the project and do research and dig into it?
Oh, well, let's see. My colleague, Michael Syracuse, has given a number of presentations about it, mostly in energy focused type presentation, symposia and conferences. But now that the building's finishing construction, I think there's probably going to be a wider rollout of PR and stuff about it.
Awesome. All right, looking forward to seeing it. Dan and Spencer, I appreciate both of you for hopping on.
Yeah, thank you.
All right, thanks a lot.
Take care, guys.